Hello everyone, welcome to the instrumentation class by Shivshankar Mukherjee. So today we are going to discuss about something which is going to be the future of this world and which is going to be the main part of every system in the future which is coming. So today we are going to say about the LiDAR. What's the LiDAR is? The LiDAR is a light detection and ranging, which is going to be the future. So it was first invented from the lasers such as the radio waves, now which are being also used in LiDAR. Is that okay? So now a very semi-autonomous and autonomous cars are using the LiDAR, which is making our work easier. So the LiDAR will lead our new world of technology, increasing. It is also going to increase our employment system. So for that thing also we are getting a very much benefit from this here. So another thing is there that in the future each and everything is going to be with the AI, that is artificial intelligence, and that will require this type of system to control many other subsystems. Now we are coming to the next point, that is here. As you can see that we hear the contents, that is what are the parts we're going to discuss about this point. So there are about 20 slides, most probably it's about 20 slides. So it's totally divided into, and it's not a very big one. So it's the introduction. We are going to start with this, that's a LiDAR is a device. So LiDAR stands for light detection and ranging. From the name only we are getting that it is based mainly on the light detection and ranging. So the light intensity depends on, that is the detection, there should be a detector, and ranging, that's the distance between the source and the object. We are talking about this. So these are the three main parts which are involved in this small five letter word. So that is the LiDAR. So what's the LiDAR is? LiDAR is a device used to measure the distance. So by illuminating the target with laser light and by receiving the reflected rays with a sensor. So the Malcolm Smith was the first person who introduced the first LiDAR in 1961, just shortly after the invention of LiDAR. So now here we are going to see that what are the main things a LiDAR going to do and what it consists of and for what we are using. So difference of the laser, that's what's the difference they have made in between the laser light and in this thing. So we are not using the laser light over here, we used the basics, that how a laser light can be used in this system. So Malcolm Smith introduced the first LiDAR system in 1961, just shortly after the invention of LiDAR, and the differences of laser return times and wavelength is used to make the 3D representation of the object. So here we can say that the LiDAR was originally a portmanteau of the light and radar, so it's sometimes called the 3D laser scanning. So now we can say that it was originally called as co-LiDAR, an acronym that is for coherent light detecting and ranging, derived from the term radar. So itself an acronym for the radar, that is radio detection and ranging. So LiDAR was first used in meteorology to detect the clouds and pollution. Here, as a LiDAR is a remote sensing device, that measures the large areas not by physically but with hands. It measures the automated sensors which use the high efficiency and they reduce the time to calculate. So here we can see that how much it is helping us in our future, in our present day. So this is going to be the future, that you don't have to work hard to get something, but you should work hard, so to get yourself fit. Now we are coming to this, that it directly measures the height and surface areas of vegetations without measuring each plant by plant. So you can see that for what we are using this type of machines. So these are the things which an instrumentation engineer should have in their mind, with the different innovative things, that how they're going to do each and every thing, that how they're going to make and what are the things they're going to do. So these are the parts which should be made by the instrumentation engineers, because they are involved in each and every field in this world. Even you can see from the automobile to from the electrical, from the electronics, each and everywhere they are involved. So this is the machine which is used to measure the distance of the targeted objects and also to give the 3D view of the object. So now we can say that the LiDAR instrument it was first used by the USA aircraft, that is the Hogs aircraft company, and that was the start of the journey of LiDAR, which make our life easier day by day with the advanced technologies. Can you see that from 1961 they have started? So the LiDAR instrument fires rapid pulses of laser light with advanced laser light of about up to 150,000 pulses per second. Even you can think of it that how much speed it has. So now that's a sensor on the instrument measures the amount of time it takes for each pulse to bounce back from the target. So the light moves at a constant and known speed, so that the LiDAR instrument can calculate the distance between itself and the target with a high accuracy. So it is going to measure the distance between the target from the source with a high accuracy, because there are about approximation they have told us that it is of about 150,000 pulses per second. So one pulses are coming from that object by striking with that, and they are giving a dot like pixel like things on the screen, pixel like strikings on the screen, which we can see that this is the object and this is the shape of the object, because they are hitting the object with many pulses which are coming back to the source. So this is a complex map that we are going to get, but it is making our life easier to see that object even without reaching it. Can you understand? So it consists of the 4 main parts in it. So now we are coming to the 4 main parts, that is, it consists of the laser, the optic and scanner, the photo detectors, the receiver and receiver electronics, it's the same point, and the navigation and positioning system, it is also in the same point. So now we are going to say about the laser. So in this machine, the laser which is used in this machine is from 600 to 1000. This is the range which do not affect the eyes, but there is a wavelength which is used by this system, because this system use our infrared red light, the infrared light that is of about 900 nanometer, and which really affects our eyes and which destroy the retina. So the Luminar company has made it in advanced way and make that wavelength up to 50 nanometer wavelength, and which is opaque to our eyes, and they will not affect our retinas. So machines were made with some old fashioned, with some old technologies, but nowadays they are getting advanced and advanced. So we are not going to make anything which is going to affect us, but we are going to make anything which is going to make our lives easier, but without affecting us. So this is the work of the engineer, that what they are going to do. So they are the genius ones who never ever think that this is going to get, they always think about that we should have the disadvantages lesser. There should be at least maximum number of how much they can give. They always try to give the best to make the number of advantages more. So that is the work of an engineer. Yeah. So now it's coming to the point, that is the optics and scanner. The speed at which the images can be developed is affected by the speed at which it can be scanned into the system. So a variety of scanning methods are available for different purposes, such as azimuth and elevation, dual oscillating plane mirrors, the dual axis scanner, and the polygonal mirrors. So the type of optic determines the resolution and the range that can be detected by a system. So the photo detectors and the receiver, what's the receiver electronics? So what's the function of this one? The photo detector, as we know, that is, it is a device that reads and records a signal which is going to return to the system from that object. Yeah. So there are two main types of the photo detector technologies, that is the solid state detectors such as the silicon avalanche photodiodes and the photo multipliers. Now the navigation and the positioning system is the main part, because the LiDAR mainly is most of the LiDARs are used for this part only, because when a LiDAR sensor is mounted on a mobile platform such as satellites, airplanes or automobiles, it is necessary to determine the absolute position and the orientation of the sensor to retain the uneasable data. The global positioning system provides the accurate geographical information regarding the position of the sensor. So now you can understand that it is the system which can even say what's the position of that device on which it is mounted. So an inertia measurement unit records at the precise orientation of the sensor at that location. So that means it is giving a precise position or the location where that device is. So it is used for navigation and positioning also. So it is used for, we can use it also. So from this way we can come to the working principle. What's the main working principle of this thing, and this is the main part. We should first understand that how the system is working. So now the main part is that a LiDAR follows a simple principle. We don't have to think that too much. We are going to think like this, as the shine a small light at a surface and measure the time it takes to return to its source. So this is the time source. You have to see that how much time it is taking from the source to that mirror and from that mirror to that source. Yeah, you cannot measure with your eyes or with your clock. This is as time travels very fast. It is about 0.3 meters per nanosecond. So you cannot see it or you cannot measure it through a clock. So there should be the equipment we have to use to measure that. It's okay, it is different thing, but that is the main motto, that is we have to measure the time of flight. So that the equipment required to measure this needs to operate extremely fast. Only with the advancement in modern computing technology has this become possible. So for the computing technology we are having today, this thing has made us possible that to measure the distance, to measure the time taken to cover that distance between that two object and the source. So the distance, what's the formula they use to measure that distance? So that is the speed of the light they're taking and the speed of the flight they're taking. But the light is following the two paths. It is going through one path and then coming through another path. No, I'm not saying that it is making that one. Yeah, we are just imagining and we are just trying to understand that how the light is coming. So it is just going through one path, coming through another path. So it is traveling the two times. So that's why it is divided by 2. So what's the formula to measure the distance? The distance equals to speed of light into time of flight by 2. Now the LiDAR functionality. If a LiDAR instrument fires rapid pulses of laser light at a surface, as I have told, it's about 1,50,000 pulses per second. So a sensor on the instrument measures the amount of time it takes for each pulse to bounce back. Now that is, by repeating this quick succession, the instrument builds up a complex map. So with the airborne LiDAR, other data must be completed to ensure the accuracy. So as the sensor is moving, height, location and orientation of the instrument must be included to determine the position of the laser at the time of sending and the time of return. So this extra information is crucial to get the data's integrity. From here we can say that with a ground-based LiDAR, a single GPS location can be added for each location where the instrument is set up. So it is making our life very much fast, and it is making our life easier to make us understand that what are the things is going on around us without even reaching to them. So but it has some ranges. So what's the basic design it is included in the system? If we are taking the basic parts, that is the basic structure, it includes, that is the transmitter, that is the radiation source. After that it's striking from there, the light is striking to that object, and after that the light is again coming back after reflecting from there to the receiver, which is very much closer to each other, that is the transmitter and receiver. It is about an hairline distance between them. So that is the point where the system, that this thing is going to be controlled by a system. So after that stage we are coming to the system control or the data acquisition. That is, the system control is controlling the system, that how and how much time it is taking and how they are coming and through what path the light is following and how it is how the object is, and these are the things the system is going to control over there. But from the system control there is a data analysis and interpretation. So data analysis and interpretation is the part which we are seeing on the screen, that is a 3D representation of that object. But this 3D representation is only made by that light with the help of the system control. So that light is coming from the transmitter, so that transmitter is sending a light to the object, and from that object it is getting reflected back to the receiver. So we are including, there are four main parts, that is the transmitter, receiver, system control and the data analysis part, that is the monitors and all those things which we are getting the display. So these are the parts we mainly require to make the basic structure of the LiDAR. So the system consists of these four parts. So now in this system the radiation source sends infrared rays, that is a wavelength of 1550 nanometer, as I have told you earlier, that is about from 660 to 1040 nanometer of wavelength, it affects our eyes. So this ray hitting the target objects and get reflected back to the receiver, which sends the signal to the microcontrol unit, where the microprocessor is setted with some functions, which is getting to understand that this system, this object is for this object is a tree, this object is a field, this object is a water body. So these are the things which the microprocessor is doing, which is controlling by the system which is stored in it. So there is a microcontrol unit, so that's a system control unit. It's okay. After that, the system control part then sends the output to the monitor. So now we are coming to the circuit diagram, and this circuit diagram is taken from a company. So today a modern company, and they have used the system in the car. So this is the system which is the car is using, and it is mainly using the car battery, that is the battery input protection we have to take. From there the system is taking the input. After that we are taking the battery and the system power supply. Then we are coming to the memory. So this memory is stored with what are the things the system can have, what are the things the system can have around its surroundings. So this is the memory part. It's okay, it is in a different way. So from the battery and the system power supply we are coming to the processor power supply. So the processor which we are set it in, it also needs some power supply. It's okay. From there we are coming to the digital processing, that how the microprocessor is working. So we are saying about all those things, what is happening inside the microprocessor. It is the digital processing, and from that digital processing the laser pulse is generated, and the laser pulse is generated, and from the vehicle interface, that is the sensor fusion and scan network is connected with it. And from there we are coming to there is some 3 to 4 types are differently connected, and they are, that is the circuit, and that is the diagnostic, and the monitoring part is different. It is internally connected after the whole circuit is completed. It's also having a light sensor, because the day and the night it makes some difference, so there should be a difference in the 3D images which is making it. So this is the circuit of the LiDAR made by the Texas company. So from the modern automated cars, so this gives a 3D image of the object which is displayed on the screen and helps the pilot to detect the obstruction on its surroundings. So this is a very much helpful to our lives, because it is the 360-degree sensor with the screen. So can you think of it, that how much it is helping us? So the modern sensors are totally connected to the LiDAR and a monitor which display the 3D image. So the Texas company made this modern LiDAR for the autonomous and the semi-autonomous vehicles for the future. So can you get from this that the system consists of a power supply, memory, process power supply, digital processing, laser pulse generating, analog front end, the light sensor, mechanical beam steering, clock, monitor, and vehicle interface, and there are many small chips and the parts which are connected to it. So it is a complex system, but when the system is totally done, your life is going to get easy. So what's the function? What's the duty of our engineers? To make that system, to make our lives only easier. So we have to make that thing. So these are the parts where an instrumentation engineer works, where what the thing is going to be done by that chip, where the thing is going to, we have to do before thinking the machine is doing. So that is the fast days which are coming to our life. Now, how the LiDAR detection parts, that is the types of LiDAR, that is a airborne LiDAR and a terrestrial LiDAR. So the airborne LiDAR, that is a subsystem installed in either a fixed wing of the aircraft or a wing. The infrared laser light is radiated towards the ground and gets reflected back to the airborne system receiver, and that airborne system are of two types: topographic bathymetric LiDAR. So the terrestrial LiDAR, there are the two main types of terrestrial LiDAR: mobile and static. In case of the mobile acquisition, the LiDAR system is mounted on a moving vehicle. So in case of the static acquisition, the LiDAR system is typically mounted on a tripod or a stationary device. So both the LiDAR sensor consist of an eye-safer laser. So the terrestrial LiDAR collects every dense and highly accurate points, which allows the precise identification of objects, and these dense point clouds can be used to manage facilities and conduct highway and railway service. So even create the 3D city models of exterior and interior spaces, to name a few examples. That is, there are many things a LiDAR can do. So it has some disadvantages also, but yeah, there are much more advantages which is helping and making our life a much easier one. So generally there are the two types of LiDAR detection methods, that is the coherent detection and the incoherent detection. So the coherent systems are the best for the Doppler of phase sensitive measurement, and generally they are used by the optical heterodyne detection. So this allows them to operate at much lower power but has the expense of more complex transceiver requirements. In both of these LiDAR, there are two main pulses models, that is the micropulse they are using and the high energy system. So the micropulse system have developed as a result of more powerful computers with greater computational capabilities. So the higher energy system are the more commonly used for atmospheric research, where they are often used for measuring a variety of atmospheric parameters. So if we move to the modern technologies, what the LiDAR is using. So the LiDAR we first used in the aircraft company in USA. Now it is being linked with the GPS system, as because nowadays the flights are also using the autopilot modes, which is only possible for the LiDAR if it is linked with the GPS. So the LiDAR is becoming much more popular in vehicles also, to make it an automatic, because to decreasing the people to work. So LiDAR is used to grab the information on the road, and it is passed to the computerized system to make a human being like decision. So can you think of it that it is working as an AI? So it's totally different from the AI, but it is unlike AI, which is making and helping ourselves. So for example, the LiDAR can detect the road yellow lines, which will tell the vehicle to stay within those yellow lines. So can you think of it, that how much it is making our lives easier and safer ones? So nowadays vehicles uses adaptive cruise control, that is the ACC, which has the LiDAR technology, and for that only it helps the pilot to cruise the car or to control the car. So that is the cruise control to slow down when there is a vehicle in the front, and also to speed up when there is no traffic. So these are the helpful things the LiDAR is doing. So we can talk about the semi-autonomous and the autonomous vehicle. The semi-autonomous vehicles, that is the vehicles segment, is estimated to be the largest segment of the LiDAR for automotive market in 2025. So but the vehicle market is expected to drive the demand of low-cost LiDAR sensors. That's because several major companies like the GMC, the Audi, Ford and Volvo, they are developing the innovating fully semi-autonomous driving technologies with the help of LiDAR technology. So these are the companies which are helping us to understand that how to make and how the system is working. So these are the things we should understand. So the autonomous vehicle, if we are coming to the autonomous vehicle, it is a segment is estimated to be the fastest growing segment of the LiDAR for automotive market in 2025. So the companies are researching on the ways to reduce the size and the cost of the sensors, so they really get deployed inside the car. Of course. So as a step is the direction was taken recently by Velodyne, which is introduced its new compact device using the USD 7999, and the company also travels to avail the LiDAR device for autonomous vehicle at the cheapest price range of USD 1000. So the ecosystem of the semi-autonomous and autonomous consists of the manufacturers, and they are the totally branded, like the ecosystem of the semi-autonomous and the autonomous vehicles consists of the manufacturers such as the Volkswagen, the Daimler, the Nissan Motor, the Robert Bosch, the Continental, AG, the Google, Cisco System, Tesla, Western, and suppliers such as the Continental, Robert Bosch, Delphi Automotive, Denso, and the Valeo. So the semi-autonomous vehicle requirement, there are many things. So the adaptive cruise control, lane assist, intelligent park assist, that is the APA, smart park assist, that is the SPA, automatic emergency braking, blind spot detection, the collision warning system, the cross traffic alert, the traffic jam assist. So these are the things we require in our system to make that LiDAR. So by the components, semi-autonomous and autonomous, the artificial intelligence, radar, camera, LiDAR, ultrasonic sensor. So these are the components we mainly require for the thing. By the fuel of the semi-autonomous, conventional vehicle, hybrid vehicle, electric vehicle, all the four are totally can be used to can we use this LiDAR? Because these are the machines, these are the vehicles which is going to get at each and every vehicle at a low cost also. Autonomous, that is a conventional hybrid vehicle, electric vehicle. So there are many different cars which are having this system in it. So here in this picture, there is a system consists of the LiDAR sensor, that is the ultrasonic sensor elements, radar sensor elements, there is the image sensor, GPS, and a microprocessor with a system. So there are many LiDAR sensors, ultrasonic sensors, the image sensors, radar sensors, and GPS. So there are many things we have to use in this. So the ultrasonic we are using, the LiDAR sensor also we are using. So there are many parts are there that we are using to get that LiDAR in a very advanced way. So now we're coming to the advantages and the disadvantages. So the low visibility is there in case of rainy days, on the foggy day. So there is a very low visibility for the LiDAR. We cannot see the objects very clearly. So there might be a chance of any accident in the roads and in waterways and in airways. So for that thing, it has some alternative method also which the companies are making. The cities are using these systems as the traffic sign signals and road markings also. Even the close proximity maneuvers, whenever this ultrasonic sensors are very reliable to the shorter distance, making them ideal for close quarters maneuvers like parallel parking. That is, the image sensors and LiDAR may also assist. Now the highways, the LiDAR is ideally for the highway driving task like tracking the cars and keeping the adequate following distance at a speed. So there are many future prospects that we have to see. The LiDAR can be used in drones to provide safety for the military camps. We can make the autopilot modes more advanced one, more and more advanced ones, which is having low traffic in the air automatically without being informed by the peoples on ground. To the LiDAR can be used for the archaeologists to unearth many archaeological areas where the earth cannot go easily. This will make the work of archaeologists easy day by day. So Volvo trucks, they are using the highway connectivity to link the trucks going to the same place through the same path of same companies. So this is the future coming to the control over speeding and to provide relaxing time for the drivers, so for the pilots, by selecting the autopilot mode. So here we are going to conclude, that is, as we have seen, the vehicles are becoming autonomous with these new technologies. By the airplanes already have the autopilot modes in which helps the pilot to take a break. So this way only the engineers are also trying to take some models which will be cheaper in the future world to accommodate this costly instrument each and every private or commercial vehicles to provide safety. So we can use these LiDARs in the drones also to detect any problem to the safety of the society. So the LiDAR is going to be the future of the world. So here in this case we are having the references where you can get many ideas about the LiDAR. So here is the end of the slides. So now if there is any question about this topic, you can ask me in the comment box. And if you like the video, please subscribe it, share it, and press the bell button to get the notifications about this. And really please like the video. If you like the video, please select the like button. Thanks a lot.